Thanks. Hi there, guys. Thank you so much for coming. Last talk. So let's go for it. So first of all, a few words on us. So I'm Idit. I'm the founder of Solo.io. We have an amazing open source project. Everything that I will talk about today is open source, so please go check it out. I think that you will benefit from it. So let's try to talk about the problem that we're trying to solve, why we even here. So this is 3 different ecosystems the way I see it today. There's a lot of the people who are actually still using a monolithic. That's what they're going to use. They're going to use different tooling for that. Then there's some people that already moved to microservices, and all the architecture is microservices, and there is a serverless ecosystem. There are 3 different ecosystems. Actually, there is not a lot in common between them. If you will use in one of them, for instance, some monitoring tool, most likely in the monolithic, you will use something like APM. Then if you're going to move to microservices, you need a way more scale, so we'll move to something like Prometheus. And if you're going to serverless, you're probably going to run on the cloud, most likely, because in my opinion, this is where it makes the more sense. Then you will use the cloud provider monitoring. So there's quite a lot of different ecosystems, different tooling. And what we're going to do right now is we will try to see how we can actually merge them together, and not by actually services, but actually tools. So we'll look at it. So first of all, I just kind of like look at the tooling that you will use if you use something like monitoring, monolithic application. So most likely it will be one big binary. It's going to use something like Ansible, Chef, Puppet, and so on to actually manage that. You're going to use something like Splunk, for instance, to actually collect the log. And the architecture itself will be service-oriented architecture. But if you're going to move to microservices, you're most likely going to use Kubernetes distro, or anything of that, like either Docker or DCOS for Mesos and so on. You're going to use a different, as I said, metrics or monitoring tool, because the scale now in this distributed, it's way higher. So you will need somehow to use something that's capable of scaling so much. You probably will need to use something like open tracing or open consensus, because now your logs is basically spread all over around. And you will need some transactional logging to understand where the request actually went from all this replica of the instances. And then the last thing is that the architecture will be microservices. We bring it to the last one, which is serverless. If you're going to serverless, I'm a big believer, so serverless need to live in cloud. It makes way more sense when it's on rent. And the reason is, if you think about why it even exists, AWS did it exactly for that reason, right? I mean, they have all those services in the cloud, and they need something to glue them together. And therefore, they decided to do those functions. If you're running on-prem and you don't have all those services hook up the way AWS did it, make way less sense. So if you will run on cloud, and this example is AWS, just because Lambda is probably the oldest, you will use something like CloudWatch to actually look at the monitoring, something like X-Ray, which is basically transactional logging, and it's all about event-driven, right? I put something in S3, bang, it spins up the function. So that's great, but the question is, now I have all this technology. Maybe I have something running already in my infrastructure, maybe I want to move to microservices, maybe I have some functionality in this application that actually make more sense to do in serverless. But if I will do this, the question is, how do I manage it? Am I going to go to 3 different monitoring tools to actually figure out what's going on? That doesn't really make sense. So what I try to do is to figure out how we can actually merge those environments. And the way I see this is that if you're trying to do this exercise, the best way to do is to find what is the smallest unit of compute to actually share between those environments. And in my opinion, this is function, right? If you think about it, what is a serverless? Serverless is basically an API call that's calling a piece of code. That's not that different than microservices. It's just they're going to be more function in the same binary. And then that's not different than monolithic application. Again, an API call that's calling a piece of code. It just means that you will have more function in this binary. So what if somehow I will manage to actually break my application to function? And when I'm saying break, I'm not really mean break. I mean discover them all and then basically be able to route to them. Then I can do something like that. And that's what I'm calling hybrid application. This is the ability to actually create an application that consists from different type of architecture. So let me show you how something like that is going to work. So we see some demos. By the way, I don't know if I mentioned it will be technical. I don't know why he said no. OK, so. OK, so in a sec, I'm going to spin up in AWS in the east, so it will be a little bit slow, but we open everything we need. Cool. OK. Awesome. So I have a monolithic application. This is the hello world for Spring application, right? Everybody knows that. It's pretty obvious. It's actually not something that we wrote. If you look in this, it's actually written by the Pivotal guys. And they wrote a very simple monolithic. Sorry, can you hear me still? Oh, fine. OK, monolithic application. So we just took that code, and it's complicated as you can imagine, a monolithic application. All the code is here and so on. And it's working, right? If I'm going to the browser and I'm actually looking, you can see that I can easily browse and see everything that exists there. And it's working fantastic. But here's the thing. I have a new engineer in my team. I really want to add a new column here. What does it mean that this guy needs to do? So the first thing that you need to actually learn the code itself. After you learn the code, you need to actually add the functionality. Then you need to test it. Then you need to regression test it to see that it didn't break anything. And only then you need to redeploy monolithic application. That's quite a lot to add a new column. So here's what we're going to do instead of it. So I wrote a very small Go microservices application here. Basically, the only thing that it's doing is going directly to the database, getting all the information that I need, render an HTML, and serve it. It's pretty simple, reading in Go. But again, this is all it's doing, right? So now let's go see our product that we built called Gloo is all open source, help to glue those together. So what we're going to do right now, this is the UI of Gloo. Everything that I'm showing in the UI, it's basically translate eventually to a CRDs in Kubernetes in that case, which means that you can use it with YAML file, you can use it from CLI, you can use it also from the UI. So when I'm clicking on this, we're already taking advantage of the platform that I'm running on. And in that case, it's OpenShift from Reddit. So I'm just going to log in with the credential, and I'm already see what I can see. Can you see that well? It's big enough? More bigger? OK. Let's try to do this. Better? More? OK. OK, cool. So basically what you can see, that Gloo already, just by installing Gloo, we have a very interesting discovery system that already discovered a lot of stuff that are running on my infrastructure. So let's see what we have here. So the first thing that you see, there is a lot of Lambda function. It's basically discover some Lambda function that's running. We can go to it and see that it's running on East 1, right, in US. We can see that there is other function that it discovered, like basically a Swagger Open API function that running on Kubernetes. This is what you can see here, right? It's running on Kubernetes as a service, but it discovered even the spec of the Open API calls. We can see some of gRPC. So it discovered some gRPC function that running on Kubernetes. And it discovered quite a lot of services that are running on Kubernetes. So now if we will go real quick and we'll do the pet clinic, which is the application that just ran, you will discover that I have these things, which is basically the monolithic application lift and shift. I have this. That basically is the database. And then there is the Go microservice that I just wrote. Now, we can go to the route and can see that I basically define an application called default. And in default, I have one route, everything going to the monolithic application, right? So now we'll do something pretty simple. The only thing that I'm going to do is I will come here, go to the pet clinic again. And what I'm going to do is I'm going to add the Go microservices to the default application. And here I will say every time that in the browser someone going to /vet as a prefix, go to this Go microservices. And that's all I needed to do. So now if we're going to the route, you will see that now I have two routes. But the thing is that /vet is also slash, which means that slash will take everything. So what I need to do is to sort it. And sorting is pretty simple. I just move it up. So now it's first going to look for search vet, and we'll go to the Go microservices. Otherwise, it will go to the monolithic application. So now let's see how it works. It's pretty simple. So this is a Java application. And when I'm clicking here, this is a Go microservices. You see, this is already updated. So now basically we merge those two environments together. But there is another thing that's not working here, and this is the contact. Every time that I'm clicking on the contact, it's not working. So what we can do, pretty simple, is we're just going to try to, for the fun, to run a Lambda here. So every time that someone will click on this, it will run a Lambda. And I can edit from here, from this UI, right? Just find it and edit like we did before. But just for heck of it, we will go to the route, and we will edit from this page. We're going to say, to the default application, every time that someone now going to /contact, I want to go to LWS. I want to collect, to call the function contact from tree. I want to do it synchronized, and I want to enable transformation filter, and I will explain in a second why. So now, what is the transformation filter? So Lambda is already returning JSON, but I really want to show you here HTML. So what we did, we extended Envoy, which is the proxy, and we will talk about it in a second, to actually support transformation. So you can choose to transform whatever protocol you want to whatever one you want. So again, what we're going to do, we're just going to put it on top of the slash. And now when we're going here, this is a Java monolithic application. Every time that I'm clicking here, I'm going to go microservices. And when I'm clicking on top contact, this is a Node.js spin up in AWS every time that I'm doing it. So basically, this is an hybrid application. This is an ability to take. Now, why it's important? It's important because if you really want to migrate your application or add them, you need to choose the one that is right for the architecture, and not using something because then how am I going to monitor it? So what Gloo is also doing, it's basically collecting all the data from all those monitoring and bringing it to one place. So that's that. So now let's go inside the deep dive, and we'll see what else tools we can give to actually help now debug, monitor it. I saw this hybrid application. When my computer will wake up. OK. OK. OK, so a few things just about what you just saw. So what you saw right now is a product that is, in terms of the technology, is the edge of the edge that exists. It's built on top of every open source that is reading here. Sorry. Based on top of Envoy, which Envoy is the proxy that Lyft wrote actually to exactly do this use case, to migrate between monolithic to microservices and Gloo in the environment. We extended it quite a lot, and this is what's special about the product that you see here. Again, everything is open source. Go check it out. The other thing is that it's built in a very interesting architecture that you can extend it. And I think this is something that's very interesting. So the technical people here, we are basically watching storage, either CRDs in Kubernetes or something else. And once something changed, we basically immediately detect it, sending it to a plugin system that knows how to translate it to, in that case, Envoy proxy. And then just aggregate it back and position it. That means that if there is new feature in Envoy, we immediately can get them. And if we want to write something, we can go very fast. That means that we can always be on the edge of the edge. And there's a lot of interesting technology, other technology that we did here, like, for instance, the GitOp integration. So you saw quick when I changed something in the UI, it's immediately changed on the network, which is kind of like dangerous, right, if I messed it up. So for that, you need some way to actually protect yourself, and the way to do it is basically the UI or the CLI eventually translate to a YAML file that is being checked into Git on your advance, and so on. So we talked about the discovery system. So the discovery system is one thing that's actually pretty simple, interesting about what's going on here. And the fact is that we're discovering everything that you have in your infrastructure. So we're discovering your instances that you're running on. We're discovering the services that are running on top of them. And then even if after we're done finding that, we're actually going and looking to see if we can get the signature of the function. So something like OpenAPI Swagger, WSDL, gRPC, GraphQL, we discover them all. Because if we do know the signature of the function, it's giving us an ability to be more interested, more protective. For instance, in terms of security, if we know what we should expect, we can actually not move it on if it's not a good idea. The other thing is that also it's going to help us help you with the transition. The other thing is that we're discovering all the serverless function that exists out there. So this is the example of what we're supporting. But the interesting, in my opinion, the most is the Knative one. So Knative, when they actually got out, it's coming from Google. When they got out, they basically was depending on service mesh called STO, coming also from Google, that it's a big monster. But they didn't need all of this in order to support that. So they basically look for a different ingress that can, or API that can help them, and they choose Gloo. So Gloo is by default running in Knative. But as I said, architecture is pretty interesting. That way that it can extend if our purpose is actually gluing environment. So we need to make sure that we can run everywhere, we can persist our storage anywhere, and we can actually also watch the secret. So I will explain you what we're doing here with the security and the secret that it's very interesting. You saw me running a Lambda function right now. What you didn't notice is that in my, because I didn't show you, that in my client, I actually didn't put any secret or a API key. And the reason is because Gloo is watching something like Vault or Kubernetes secret. And every time that there is a rotation, Gloo is detecting it, sending it to Envoy. So then when the request path is coming, when the request is coming, it's basically piggyback that, creating an handshake with AWS, just make sure that it will work. Which means that something rotates, you don't need to worry about that, which I think is very comfortable. So that's what we just did, right? We basically, if you think about it, we glue the environment, but we basically glue the client because the backend is still totally distributed. And there's no relationship between the backend. Like, as you can see here, there is a function plus and a function multiplication. There is no connection between them. When we thought about it, we said, can we create any connection between them? And we thought that we can. And what we did, we thought about GraphQL. Think about what GraphQL actually is doing today. GraphQL is doing something like that. What it's doing is basically the ability to actually go to one function, collect the data, then send it to a different function, collect the data, and eventually represent the answer. So it's basically doing a flow of function, if you think about it, right? What everybody's trying to do with, how do they call it, Lambda workflow or something? I don't remember what it's called. But basically, that's exactly what they're trying to do. But GraphQL giving you to do that with a very simple language of query language. So what we did, we basically said, Envoy by far is the best proxy that exists today in the market. What we built here is very interesting because we are routing on the level of the function, not like other hosts. So what if we can actually build a GraphQL on top of Envoy, and the resolver, which is basically explain which function to call with, we can actually always point it to Envoy. And because Envoy is all about configuration, we can actually change it and define it without changing anything in the application itself. So I will show you what I mean. And again, everything is open source. We're calling it Scoop. It's open source. Go try it. I think it's pretty cool. So I'll give you a really small example. I have this application that I will make it a little bit bigger, but it's basically just a company, and there is two divisions there. The first one is human resource. It's HR, and this is all the people that are working, and if they are good or not, right? It's basically what is the performance valuation. Then there's the engineering. And the engineering, basically, it's a different division. And I can go and look to see what is the project that's running right now in the company, when is the deadline, what is the budget, and so on. I can also see that there is a finance division. And the finance division is basically holding all the salary that exists in the market. But what you don't see is that it's basically three different type of application. The first one, it's basically the finance. It's basically a Lambda that's going to a backend service and bringing me all the function. The second one, it's basically the engineering. And the engineering is basically a Swagger open API application that's running on Kubernetes. The third one, it's actually the finance, and this is gRPC application. So three different totally applications. So now, what we can do is this. We can easily come to Gloo and basically define a new query language, a new API. That's basically what I'm doing, a new API that I wanted to support, and tell them, right, and basically said, this is the new API that I want to support. The second thing that once you do this, immediately, it's define what is the resolver, what is the field that you need to know how to get, because he doesn't know, right? You need to tell him. And what you can see is that you can easily go here, define that you need to get the first name, and just basically from the list of everything that was discovered already, just choose which function you want to call. And you can see that here in this application that I showed you before, there is a Kubernetes service, This is how we define it. There is a Lambda service and so on, and you can just see how you can glue them together. If you're going another thing that you're getting with Gloo is basically, with Scoop, is basically a GraphQL playground. So this is your ability to actually come and say, oh, I wonder what the query should be. And it's auto-complete. So now what you can do is just click on this, and it's going and basically doing exactly that, right? It's basically did a flow, went to one function, gave me the information, went to the other service, gave me the information. Because we built on Envoy and we added a lot of functionality, it's all cache, and even security is embedded in inside, which I think is really cool. And here I did the same thing, just with reports, right? So you can get the information on everybody that's working, their performance is good, but they got less than 70K, for instance, right? So that's kind of like the ability to bring everything together. So now, hopefully, that will be more interesting. We will talk about, OK, so we have this application all together, right? The only question is, how do you debug them? How do you actually unify the toolings, which I think now it's the biggest problem that exists in the market. OK. So this is the tooling the way I see it today, right? This is what, at least when we were on monolithic, this is what we needed to have. We had the metrics. We had someone to take care of the logging, something to take care of debugging, something to take care of the architecture, development, and testing, deployment and testing. So if you're looking at this, for example, in metrics, you have APM for monolithic, Prometheus for microservices, the most famous one, and CloudWatch for Lambda. But think about what we just did with Gloo. We're basically invoking every function that exists in the market, in the ecosystem, even if it's a Lambda one. Which means that we can go, and then we have the idea to suck the information from everywhere and bring it to you to one place, for instance, Prometheus, but it can be everything. If you're thinking on the logging, it's actually way more interesting. Because you can use Splunk when you have a monolithic application, but when you started to actually using instances and replication, there is a lot more of service instances, and you don't know where the logs are. And usually you're getting a lot of logs, but you don't know how to correlate between them. That's what Open Tracing and Open Consensus is doing for you. They're giving a transaction ID on the beginning of the request, and then they're following up. They're only taking the headers, so you need to block that. But eventually you're getting what's called a span, which is an ability to actually see, oh, microservice A, call B, call C, that call D, and here is all the logs that I've collected. That's very interesting, but again, it's in Lambda, you have something called X-ray that AWS is providing you. But because we're actually the one that invoking everything, we can actually make sure that to bring all this information and create a span that it could be those logs is for monolithic, those logs is for microservices, and those logs for serverless. So basically, you connect all of them together. Now debugging. Debugging, this is where I'm very passionate about. I mean, if you see, every time that we had something in monolithic, we managed to create a tooling with monolithic, we created tooling in microservices or serverless. But what we didn't do is we never solved this problem of debugging. And debugging is amazing. I mean, there is no better feeling than just take a monolithic application, attach the debugger, and understand everything that's happening in the memory on the same point. But what we're doing with microservices serverless is troubleshooting. We are not debugging anymore. And that's why we created a tool called Squash, and I will show you a demo in a sec. Architecture is the same thing. There is SOA architecture, there is microservices, and they're event-driven. But who said that event-driven can be also for microservices? So that's also something that we did, that we're giving you the ability to basically use something like NATS or Kafka to actually spin up an event. And then we should fix the development and the testing. So I will show you 1 second the debugging. I'm a big fan of debugging, so I will show you why kind of like I feel that this is a strong problem, and I will show you how we solve it. So the first one is, why do we have a problem? So again, we have a problem because before we had one big binary. When we have this one big binary, it was pretty simple because all the state was inside. So if we're actually going to attach the debugger, we will see everything that's happening in the memory on that point. And that's great. But that's not the case anymore, right? We decided to go distributed. When we go distributed, never mind if it's serverless or microservices, we basically just took the state of the application and spread it all around. So now the state is not in one place, so you can't just attach debugger. You don't know what's going on the others. And that's very problematic. It's also problematic to know where to attach the debugger to. It's a really, really big problem. Now, I saw example of microservices. This is actually how people actually running microservices today in production, right? There is like 500 plus, so that's a lot of microservices. So how are you going to manage something like that? And this is a tweet that someone tweeted not long time ago, and I really, really like it, because I think it's really true, right? You're moving, and then good luck. So the question is, how can you actually fix it? So I will show you what we did. It will take a second, because I need to spin it up. But basically, this is what we thought that we should do. So I will start the demo. Give me a sec. Sorry, it will wrap the cluster, start it again, all in east, so it will take a little bit of time. But we'll put it. For the meantime, I'll explain you what we're going to do. So, and we will, once again, just let me verify that's actually working. So it's terminating. It will take a sec. OK. We'll give it a time until we terminate it. Anyway, for the meantime, I will explain you what we're doing. So there is these debuggers. There exists, right? You can actually attach a Java debugger. You can attach a Go debugger, C++. There's quite a lot. The thing is that we're just going to verify that's actually working. OK, so we give it another second. If it's not going to work, I'm going to just kill it myself. So all these debuggers are already working and exist, and the question is, what can I do in order to actually orchestrate them to simply work in environment of microservice and serverless? And that's exactly what we did, and I will tell you, we're almost there. Last service, all your choice. If not, I'm just going to kill it. I think it's not killing out. I'm just going to kill it. Give me a sec. Let's see that maybe now. No, so I'm going to call it. It will take a second. I'm sorry that you need to see that. It's just an old cluster. Just going to kill it manually. If it's not going to start right now, yeah, so I'm just going to kill it. Then we'll be all good. It's fun. Needed to talk to the demo got before. OK, now it should work. Yeah, now it's continue. The second one, we'll see it working. Yeah, starting. Awesome. So OK, so that's basically what we tried to do here. Basically, what we did with orchestration of debugger. We just basically want to make sure that it will be really, really simple for you to debug your microservices. There is a little bit timer right now just to make sure that everything is connected there, and then I will show you the demo. So what we're going to show here is that it's basically a very simple application. It's a calculator that basically what it can do is just add or subtract two numbers. It's pretty simple. Here you go. It started. And I will try to run it and choose two numbers. It doesn't really matter which one. And I'm going to calculate it, and we'll discover that it's not working. And that's pretty annoying. So what people usually doing when something like application with microservices and serverless is not working, they start to troubleshoot, logs. Or maybe they're using some open tracing capability, so then they need to wait, add it maybe to the log, and then wait for 10 minutes until the log will come in order again to troubleshoot. That's not debugging. So what we did instead is this. So let's understand what is this microservice application. So basically, it's pretty simple. I have a Go microservices that basically just serving the HTML. That's what you can see here. It's pretty simple. It's serving the HTML of this page. It's taking the two parameters, and when you get them, you're moving them to a Java microservices that's running here. So it's this one. It's just a very simple Java microservices that either add them or subtract them, and then return the result. So it's overcomplicated calculator. Now, this is running, the Go microservices is running on Visual Studio Code, just to show you that we can do any IDE that you want. And the Java one is running on the IntelliJ, just again, to show you that we can. So here's how I feel that we should debug our microservices and serverless application. Basically, we created an extension called Squash. when I'm actually going and ask Squash, I can choose Squash debug container. What's happening immediately is Squash going and basically represent me all the pods that are running in my cluster. This is service 1, so I will choose the first one. Then he said, look, in this pod, you have 1 microservices. Do you want to debug it? I will say yes. And then he will say, which debugger do you feel like attached to it? And this is written in Go, so I will go with the DLV debugger. So that's it. So now that's running in East. Hopefully, the network will play nicely with us. But that's it. I attach the debugger. Now we'll do exactly the same thing in IntelliJ. We will write Squash debug container. We're going to choose service 2 Java, because this is Java. And then we're going to choose the container that's running there, and we attach the Java debugger. So we attach the Go debugger, the DLV to the Go code. We attach the Java debugger to the Java code. And now the only thing that I need to do is just basically click the button, and that's it. I'm debugging it. So I can actually easily step into, and you'll see here, and hopefully it's big enough for you guys. You can see the numbers. You can see that we said true. I wanted to add 34, 80, 89. Now, what will happen when I will click next? So we'll jump to the other microservices, right? Because I put a breakpoint. And again, I can see that everything is working. I'm going to step into, again, it's in US East, so it's a little bit slow. But you will see in a second that I can actually jump. And what you can see is that it's true. It's good, right? The ops 189, and the ops 2 is 34, and the is added equal true. But look what I did here. I specifically introduced a bug, right? What I did is I said, if it's true, created a minus and not plus. But this is simple. This is a regular debugger, right? This is the Java debugger. Let's just change it online. On runtime, I'm just going to go to the is added. I'm going to change it to false in the memory, right? So nothing really changed. It's just in memory. And then what I will do next, what will happen? So we'll jump to the other microservices, because I put a breakpoint. And then when I will click this, bang, it's fixed the problem. So now I know what to do. I don't need logs. I don't need anything. I saw what happened. And you see, it was very simple. So this is how I think that we should debug it. Now imagine you jumping between monolithic to microservice to serverless. I think this is where it will be interesting. We're working right now with the Knative team to actually add it to Knative, and there is a lot more that we can do on this space. But I feel that this is the way people need to, in my opinion. That's the way we're debugging when we're writing Gloo and any other SuperGloo, any other product that we're writing, very distributed microservices and serverless. This is what we're doing. So now what I will show you, as we will continue, because there are way more stuff. Sorry. We're good. OK. So now we saw how to debug it. We'll explain a little bit what it is, just so you will know. Again, it's open source, so go have fun. So basically, Squash has 2 types of running. The first one is that if you're running locally, you don't care. You are on the cluster. You can do whatever you want. That's the default mode. The other mode is that if you're running with your teammate, you don't want other people to attach to your application. So we need to verify that you're allowed to see that. And I will explain in a second how we're doing and what is interesting about what we're doing here. So the simple one, even though I wrote secure, I meant simple. It's pretty simple. You have a container in namespace. In that case, it's namespace A. What we're doing is there is a namespace. Basically, it's a command line that it's automatically already, we're using it from the extension. Namespace Squash is just going to put the debugger and going to attach to the microservices. That's really simple. But it's not that simple. Because the question is, if both of them are running in different namespace and different container, what is the PID that I need to actually attach in the namespace of the host? Because that's my problem. And that's the really magic in Squash. What we did here, which I feel very nice, is we needed to find the PID of this application on the namespace of all the hosts in the operating system. What we're doing here is this. We're basically using we're going to, in that case in Kubernetes, to something called CRI, which is the container runtime interface. And we're basically running a command to understand what is the unique identifier of this PID. And this is how to do this. This is like an operating system, kind of like low level. But basically, that way we're getting the PID. And then the only thing we're doing is basically attach to the PID that we discover. So that's pretty simple. Again, the beautiful is that if you ask what's special about Squash is we're doing all the piping for you. You don't need to worry about it, right? We just figure it out. We're attaching everything. Boom, it's running, debug it. Now, secure mode. So first of all, I need to know that you can also debug these microservices. And in order to do this, I need to make sure that you have actually a permission to this namespace. So first of all, you need to run Squash service. That's the way we actually making sure that it's secure, which is very simple, small microservices. And then when you actually want to debug something, we're writing the intents to the namespace that the application running it. If it succeeds, it means that you have permission. If it's not succeed, we know that you cannot debug it. You're immediately getting an error. You don't have permission. But if we did succeed, Squash is actually looking to see if this CRD is added, and then same thing. Just create a container of the debugger, attach it, and you have it secure. OK, so this is great. The question that we have right now, can you debug it can you use Squash for production? And you knows that no, it's not a good idea. You don't want to attach to your application running in production something like DLV or GDB. You really do not want to do that. So what you need to make sure is that, and also it will pose your request, right? So again, not a good idea. But to be fair, we all care about production, right? So the question is what we can do with this. So I want to show you something that I'm really passionate about it, and we're working on it with Lyft, actually, because Lyft asked for it. So I'll explain you what's going on. So it's pretty simple. Let's say that I have a request coming to my cluster. It's going to all those microservices. Maybe from these microservices, it's going to database or S3, and it's getting out. There is this technology called service mesh that actually my employee is talking about it right now in the other tent, and unfortunately, because you should have probably seen that. Maybe that's where everybody. So basically, service mesh is the ability to say, well, that's too complicated. Like, that's interesting. But every time that you actually want to do something like security, like observability to your cluster, like make sure that the two microservices can reach to each other, what you need to do is actually you need to bake it inside your application code. And that's never healthy, right? I mean, that means that if I have a new library for logging, I need to then, deploy new microservices, which is, again, it's not a good decouple. You don't want to do that. So people came with this technology that called service mesh, which is basically the ability to abstract this logic. And by the way, after you're doing it, you need to give it to something like open tracing. That basically what it's doing is running this proxy that we're running. It's called Envoy. It's the proxy that we're running Gloo on. And basically, just putting next to every application, every microservices, this sidecar, this proxy, and basically tricking the IP table to talk only to this proxy. So basically, every traffic in and out from these microservices or monolithic application or anything is going through this proxy. Now, what is proxy? Proxy is basically dumb, right? It can tell to do everything, but you need to tell him what to do. And for that, there is something called control plane that need to manage those proxy. If you think about this, is exactly what we're doing with Gloo, right? We abstract the network. That's why we can do a lot of stuff, because we're on the request, but can append stuff. So if we're doing this, that means that when these things happen, when you're actually getting a request, it will go first to the proxy. The proxy can propagate it to the cloud, they're logging somewhere. You can tell him that's not allowed to talk to these microservices. You can tell him go and route to this. You can own all this technology. So that's something very popular the next year, this is, at least in the US, this is like the most interesting stuff happening in this ecosystem. The problem with that is that you didn't solve the problem of, now you can actually make the proxy and not modify your application, take the logs and put them somewhere. This is great. It's giving you observability. The problem with that is that there is a lot of logs. If you're actually putting everything there, you will kill your network. So the question, the overhead will be huge. So what people doing in open tracing, there is open tracing there's two contexts. One of them is you're only taking the headers, which means that you as a developer are responsible to put the data in the header. And the second thing, because again, then there is not so much data. And the second thing is that you have to sample. Sample is the most important art in open tracing. You can't collect everything. You will kill the network. So this is great, but the question that I ask when I try to figure out how to debug something in production is, do I really care about everything that is good? If something is good, do I really want to collect it? And in my opinion, you don't. So here's what we're doing. We basically create a top filter to Envoy, working with the Lyft team, to basically record every request that's happening. Okay? Now, it's really just buffering. It's not sending it anywhere. Now, if the request is good, I'm just tossing it. It's not even going out of the network. But if something is going bad, then when I care about this. And then what I'm going to do is I'm going to save it. But hopefully there's not so many bugs. So you will use only what is really relevant. Now think about it. The proxy is actually also piping it to the database and to S3 and also bring it to the application, which means that you basically got a snapshot on everything that went to your application and got out from your application, which means everything that you got from the database. It's like a snapshot on your environment. With Service Mesh, we can also actually see the latency between them. So now, and we're calling it Gloo, by the way. It's also going to be an open source project. So if right now I actually recorded this, it's as simple for me to just spin up the same environment there, inject the curl, do curls, and basically inject everything that happened in production and attach squash, and now I can actually debug, basically replay every production problem that I have without actually interfering whatsoever the production environment. And I think this is, will be very useful. Lyft has a different use case, but Lyft is doing, if Lyft is like Uber. And what happening if you're calling, hey, my Lyft is not here, usually what they have like a support team that have a dashboard, and they want to record everything that related to you, that you will be able to understand what the problem. So this is basically a really amazing use case. In my opinion, the feedback that we're getting about it is really big. So I mean, I can show you a quick demo if we have time, but we don't have a lot of time. Or we can defer that. Maybe we'll defer it. But it's basically, I wanted to show you what I just described. So you believe me that it's work. So I'm just going to summarize because we're out of time. Basically, this is what I show you right now. I show you tools. Those tools is all open source. You can all use it. The first one is Gloo, which is basically, in my opinion, the best API that exists out there. I couldn't talk too much about the technology there, but it's really special. The second one, and again, it's treating function as a first entity, which means that it will play very nicely with serverless. It's going to just basically glue the environment and help you migrate. The second one, it's Scoop. This is the GraphQL. Again, open source, just go check it out. And then the last one is Squash. This is the debugger that we talked. So this is what we have. As I said, I didn't have time to talk about everything that we have, but actually, if you are interested, you can go and check it out. But basically, we have SuperGloo, which is basically the best way to start with Service Mesh today. Basically, what it's doing, it's coming with an opinion API that is very simple and let you consume whatever meshes you want in really easy way and helping you to manage that. We're going to announce in KubeCon GlueShot. GlueShot is a chaos engineering on top of those Service Mesh. We're going to open source Loop, so this is what I show you today. And the last one is going to announce a Service Mesh Hub, because we believe that Service Mesh is the future for serverless, for microservices, for everything that's happening today, because the right way to actually build your application is to abstract the operation from it. And you should come and see it, but it's going to be basically very great. So that's all I have, and thank you so much. Just 3 minutes to a question, if you want.
Thank you very much, Idit.
Yeah.
I don't know, what's the time? Oh, yeah, totally. We have time for questions.
If you have any.
Let's pull up Slido, then. Let's grab a couple of questions. All right. First question is, can we use Azure Key Vault to store keys instead of Vault?
Yes, definitely. So the way we build everything that we build in Gloo is basically interface, that way that it will be very easy either to you to do it by yourself if you want to use it from the open source, or ask us, and we will do that for you. It's a very clear interface and very simple to do, so we can support anything you want. And that's the beauty.
That's pretty cool. And does Gloo support conditional routing, like, for example, for A/B tests?
Yes, definitely, and more than this, I will say. So you will see another announcement coming out for us. So there is a product called a Flagger from WeWork, and we work together to actually integrate it with Gloo, and to integrate it with SuperGloo, which is for Service Mesh, and you can do A/B testing, and it's really actually beautiful. It's watching your Prometheus. You don't need to do the traffic shifting yourself. It's just basically you're giving him a threshold, and he can do that manually. It's operator, right? Yeah.
Envoy. Or AJ proxy.
So Envoy is, look, Envoy is the future. I mean, HT proxy is solid. People running it in production. I think that in Envoy, there is, like, we needed to choose when we built Gloo. And the reason we choose, we started from scratch, so we actually could choose whatever we want. The reason we choose Envoy is because two reasons. First of all, that's the best use case. That was built for that, for migration, and that's what we wanted, to glue those environments. The second reason is because the way Envoy is built, there is a few things. First of all, there is ability to extend it for real. And that's really good. There is and I wrote a big, actually, blog that I would love you to read, basically how Envoy is working. And it's basically showing that the way the flow is working is that when a request is coming, then it's going through a filter system. And you can just write filters and make it do whatever you want, basically. Now, it's also really, really performant. And also, because Google chose it as STO's proxy for service mesh, there's a huge community around it. So, I mean, we are the top contributor together with Google, together with Lyft, together with Apple even, Amazon, everybody using it right now. So that will be the future. They're going to also, it's part of the CNCF. They're going to put, to create it right now, another layer of API. So I'm a big fan. I have no doubt that that will be the winner. So HA proxy, it's working. I just think that it's way older and hardest to work with. And in the future, in my opinion, most of the people will use Envoy. So if you're buying right now, choose for the future, not for the past. Yeah.
All right, cool. I think we're out of time. So another round of applause for Idit.
Thank you.